Hey everybody, my name is Darren and this is backend software development, creating RESTful web APIs with AWS Lambda and Node.js. So I have about 5 years of industry experience with backend software development, and this is a really popular topic with cloud computing and creating web APIs. This is becoming something that is skyrocketing in demand. If you're going to be in backend software development, then you really need to know how to write your own web APIs. And AWS is a great cloud computing platform that we're going to be talking about a little bit more in this video. So this video is for complete beginners. If you have never written a single bit of code in your life, then you can follow along with this video. And I'm going to explain everything in a way that is hopefully easy to understand. Now, if you have a little bit of experience, then this tutorial will also be good for you. If you're just looking into how to use AWS Lambda or Node.js, you can skip ahead, but I'm going to start by defining some of these terms. So what is an API? An API is known as an application programming interface, and they're used all over software, not just in web. So an API can be defined by any code function that's hosted in one location, which could be the server or a packaged file. And that code function is to be used by the programmer, or sometimes what's known as the client or the caller or the user of said code function. So this is an important distinction that a lot of people don't think about, especially in web development, is an API can also be a packaged file. So my background is strongly influenced by game development. And if you've watched the channel, then you know that most of our videos are all about Unity 3D, the game development engine. Well, that engine is simply an application that runs on your computer. And just because it's local to your machine doesn't mean that there's no API associated with it. You can even go to the Unity scripting API documentation and find all of the API functions that you can call from the Unity game engine. So those functions are located in a binary file associated with the application. Those aren't necessarily living on the server. Okay, so let's move along here. What is a RESTful API? So RESTful API is just a type of API. And REST comes from the acronym Representational State Transfer. And what REST is an API that follows several principles. The first principle here is client and server. Remember, client is the programmer or the caller. The server is where the code is actually hosted. So the client and server are separate entities such that the server does not care about what the client is doing as long as it follows the server's protocol. So what that means is the server is going to provide some functions to the callers under the assumption that the caller isn't doing anything nefarious and they're using the functions appropriately. Okay, the second principle is that the server API is stateless, which means that all of the context from the client must come with each request to the server. As the programmer or the client, when you call the function on the server is not going to have any idea who you are or what you want. So as the caller, you need to provide all of that context to the server so that the server knows how to properly respond to you. The third principle is that the server API is standardized in how information is passed and processed. And that's pretty much the core principle of RESTful APIs. And we're going to be focusing on that point a lot here in this video. The fourth principle is that the server API is layered such that only the top layer of the API is exposed to the clients, which means the API can be responsible for doing a lot of work, but most of that needs to be abstracted from the client. So what is a web API? An API that simply lives on a web-hosted server. Pretty straightforward there. And we're going to be talking about what is Node.js. Well, Node.js is an efficient JavaScript runtime convenient for use in web browsers and hosted servers. If you're familiar with web development at all, then you know that JavaScript is basically king. JavaScript runs everywhere on the web. Well, Node.js is simply a runtime for JavaScript. And what it does is it creates an event loop for you that you don't need to worry about managing. The other benefit of Node.js is that it's pretty much supported everywhere across all third-party services on the web. So if you're going to be in back-end web development, then Node.js is a pretty common tool that companies are going to be using. and it's really good to have on your resume. So what is AWS? AWS is Amazon Web Services, which is Amazon's cloud computing platform. They offer hundreds of cloud services. They're cheap, and they are really basically free for the first year. So Lambda is a service that we're going to be using in this video. AWS Lambda is a serverless compute service. I have serverless there in quotes because technically, people get confused whenever you say serverless. They think that means that you don't need a server. But what it really means is that AWS is managing the server for you, and you don't need to be worried about the details. So your code is going to be hosted from an AWS managed server, and it's only going to be executed when it's needed. So the cost is entirely demand driven. If nobody is calling your web API from AWS Lambda, then your code is essentially not hosted anywhere. And AWS is managing all of this for you. A big benefit to really AWS in general, again, is that it's cheap. And specific to Lambda, you get 1 million free calls per month, which means anytime someone calls a function on your API, that would count as one call, and you get 1 million of those per month. So unless your API is widely adopted by most developers, you're not going to have to worry about paying anything to AWS. So I don't know about you guys, but I stare at a computer screen roughly 10 to 12 hours every single day, and I've done so for the past 5 or 6 years. And I'm pretty early on in my career, and my eyesight is not great. And the sponsor of the video, BenQ, actually reached out to me recently and gave me this Screenbar Plus to test out. And I have to say, one thing that I never really considered was the lighting in my workspace and how that affects the length of time that I can work and also how well I can stay focused. After about a week of using this product, I can already tell there's a significant improvement. And really, I've always worked long hours, but being able to actually stay focused and get more work done has been a pleasure with the light bar. Not only that, but the Screenbar Plus was made specifically with software developers and IT in mind. So when you're getting this, you're not just getting some regular desk lamp. They studied the interaction between people and the lighting environment when using computers and phones and other devices. And in their research, they found that the majority of people actually work long hours with insufficient lighting, which probably has something to do with why everyone that I work with wears contacts and glasses. So if you're like me and you're suffering from eye strain, or you just simply want to work longer or be more focused, I would highly recommend checking out the Screenbar Plus light bar from BenQ. And as a full disclosure, if you do choose to buy the Screenbar Plus through the link in the description, it does help the channel and it does support us, but it doesn't add any cost to you. One of the great things about this Screenbar Plus product also is its simplicity. It just comes with 3 parts. You get the adjustment dial, the monitor mount, and the light bar itself, and you're pretty much good to go. The light is USB powered, so anywhere you can plug a USB into will be sufficient. You'll be able to get light through that. And then you have a micro USB connection directly from the dial into the light itself. The dial offers temperature adjustment as well as brightness adjustment, and it also has an ambient light sensor on it, which will detect the amount of light in the room and automatically adjust the brightness to what they consider the optimal lighting for your scene. And again, thanks to the sponsor of this video, BenQ, for sending that over to me. Again, a great product, and if you want to check it out for yourself, check the link in the description. Let's go ahead and get back to the video. So at this point, you might still be a little bit confused about what an API actually does or what it's used for. And so I want to go through a couple of examples that I found on the internet. Again, web APIs are pervasive in the web, and they're everywhere. You can't really avoid them. So what I did was I looked up public weather API, and I came across this site called Wonderground or Weather Underground. And so what I want to do is just search a location on here. So I'll go into the search bar, and I actually have one right here. Let's do Phoenix, Arizona. If I click on that, then it pulls up some information about the weather in that area. So we get the temperature, we get wind, we get what the weather is going to be like today, tonight, and tomorrow. And so there's a lot of information that comes back from that request. So what happened there was I made a request to an API with some parameters such as the location, and the API returned to me a response which contained all of this information. So what we can do is take a little bit of a closer look. What I want to do in my browser is go to just right click anywhere on the page, go to inspect element, and then I want to go to the network tab here. Now this might look a little bit different on your browser. You might have this debugging tab on the bottom of your screen, but you should be able to find this network tab. So I'm going to click on that, and then what I want to do is just complete that request again. And so on this network tab, what we're going to see is a plethora of requests coming in after I make this search request, and we're going to see we'll be able to find the specific request to actually get this information about the weather. So what I'm going to do is just click this. You can see on the right here we get tons and tons of requests. What I want to do is find the request that has something like API in the name. So I'm going to search through here just a moment and see if we can find this. So there's a few here. You can see we have API key in these requests. So I'm just going to click on one of these. Okay. And so we get some information on the headers tab whenever I click on this request. You can see the request URL, https api.weather.com/v2 or version 2. And then there's an API key, which I'm not sure if they really want to expose in that manner. Maybe not the best practice, but maybe it's okay. Maybe they're aware of that and that's okay. But regardless, the important thing is that we can actually copy this URL. And you can see this last parameter here, format equals JSON. So if we go to the response tab, we can see that we actually get some JSON. So if you're not familiar, this format here with the curly braces and the brackets, that is JSON format. So we're getting some data back from this API request. Now what I want to do as a little exercise is open up a new tab and then put that request URL into my browser. And my browser actually just returns the JSON data cleanly on this white background. So it's just returning that data, and we can actually look. We get some information. Obviously this isn't the total information that's on that page, but it's one of the API calls, and we get a little bit of information back. So you can see it's expecting maybe something about heat index, something about wind chill, something about wind gust, air pressure. So some of these values are null as well. And this is just how the API responded to my request. So we can go back and we can come back here and we could look at some different responses from APIs. Let's see if we get anything else. So here's another one. Maybe there's more data in this, I'm not sure. But that's kind of the idea. And to take this step a little bit further, we can copy this link and go into a program called Postman. So if you're not familiar with Postman, Postman is an application that lets you manage your API calls. And so here's the website. If you want to go and download that, you can follow along. Just hit this download button so you can download it onto your Windows machine or your Mac OS machine. Let's open up Postman to see what this actually looks like. Okay, so here I have Postman. I have the dark mode. If you want dark mode, you can go to File and then Settings, go to Themes, and then choose the dark mode there. Let's go and open up this new tab. You can see we have an untitled request. So we're going to create a new request in Postman. We're just going to post that code directly into that URL field. The cool thing about Postman is it does a lot of processing for you with regard to APIs. So for instance, whenever I put this in, it automatically created the query params and added those in delimited sort of in this row format. So we don't really have to think a lot about, we don't have to make sense of this URL because it does it for us. So you can see we have 4 parameters. We have API key, units, station ID, and format. And that's one of the great things about Postman is it just makes APIs a little bit easier to work with. But regardless, what I wanted to show you was we can do the same thing that we did in the browser. We can send this request up since this is a public API. And the nice thing about Postman is it automatically makes this what they call pretty print, which just means it's formatted for us, it's tabbed, and we can read it a little bit easier. So one thing that I didn't notice whenever it was all together was that we actually get some elevation information back, and whatever the station ID is, I'm not sure what that is, but we get a fair amount of information back, which is pretty cool. The other thing, the other important thing to note is not all web APIs are public like this. I had to look up public weather API to come across this. Let's look at one more example. I looked up public VIN API for vehicles. So let's take a look at that API really quick. So I looked up public vehicle API or public VIN API, and I came across this Department of Transportation public website. If you want to follow along, it's vpic.nhtsa.dot.gov/API. And I wasn't exactly sure right off the bat how to use this API, but I just took a wild guess, and I grabbed one of these random documented API calls, and I just appended it to the URL here. So just copy this /vehicle/get models for make, and I just appended it to the website name here. And when you do that, you get a whole bunch of information back. And so what I'm going to do is I'm going to copy that. I'm also going to take that into Postman. So I'm going to create a new request here in Postman. Just going to copy that in. And we can see that we get a ton of vehicles back that are Hondas. So we get the Honda Accord, the Honda Civic, Pilot, and there are a lot of models out there that I wasn't even aware of. And yeah, so there's a lot on this page. Anyway, hopefully this gives you a much better idea of what APIs are used for, and basically how easy they are to find as well. Just look up public web API. Should be able to find something out there, and maybe play around with this a little bit before moving on. So essentially what's going to happen is if I'm using this on a web client, let's say a website, I'm going to get this JSON data back, and JavaScript is really good at processing JSON. So we might have a web page that tabulates all of these results and provides this information in a more readable format. All right, everybody, we are inching towards our ultimate goal of creating our own web API. Now, the next step is to actually download Node.js if you haven't gotten that already. I recommend the LTS version. I would actually choose either LTS 12 or LTS 10. If we go look at additional downloads, I believe we have additional downloads on here. Maybe all download options. Either 10 or 12 is what you want. There's a link on here somewhere to get to version 10, but any LTS version is going to be okay. You can download this on Windows and any Linux platform pretty easily. The next thing we want to do is create an account for AWS. So make sure that you do that before moving forward. So once you've created your AWS account, you'll want to go ahead and just log in. So I'm going to go ahead and log in to mine right now. Okay, and here we are in the AWS Management Console. The thing that you'll want to do here is just look for Lambda. AWS Lambda, that's what we care about. So this is the AWS Lambda interface, and right now we don't have any functions. What we want to do is just start off by creating a function. So as with a lot of starter projects, whenever you're learning a new software concept, one of the common projects that you'll create is a calculator. So what we can do is create an API that does basic math calculations for us. And by implementing something like that, you're going to get a great understanding of how to build your own API, because you're not focusing on what the API is doing. which is something that can be anything you want in the future. You're focusing on how to just create the API. So we're going to apply a simple piece of software to something that you're learning, which is how to create an API. So what we're going to do is we're going to call this function our calculator API. And we're going to use Node.js 12. You can see that they have support for Node.js 12. And I think they have, Node.js version 10 as well. You can also see all of the different languages that you can use with AWS Lambda. But we're going to be using Node.js 12. Now, they have this thing called an execution role, and we're going to leave that on the default for now without getting into many of the specifics of what an execution role is. Basically, sometimes Lambdas will access different AWS services, but we're not going to be accessing any services, so we can stick with the basic Lambda permissions. And so I'm just going to create the function from there, and we'll be taken to the main dashboard for this Lambda function. Okay, so if your function was successfully created, then you'll already be able to see you have some example code down here, and we might not actually need to do anything with Node.js on our machine now that I think about it, but I think I will show you that workflow regardless. But we might actually be able to create our entire API strictly from this, this browser IDE. So currently what we see here is whenever we call our API, it's going to be calling this function. Okay, and this event is an object that AWS provides to us that will have a little bit of context about what's coming into the function. But without doing anything else, we can see that the response will return a status code of 200, and there will be a body that says hello from Lambda, and we're returning that response right here. So what I want to do is create a test event. So we'll go configure test events. We're just going to call this simple event test. And I'll go ahead and just choose create. And then I'll run the test and see what happens. So we can see the execution result succeeded. We can go to details. We can see that what we got back was status code 200 with the body hello from Lambda. Now currently this isn't accessible to anybody on the web. And so what we want to do now is actually make this accessible. So before we get into any more code, we want to make this accessible to the public so that we can actually call this function from our API. So this is going to be really simple with AWS. All we want to do is add a trigger. So I'll go back in case you missed that. We're going to add this trigger, and what this is essentially you can add triggers. Multiple AWS services can be triggers to your API that actually call this function and run this code. The trigger that we're going to use is going to be called API Gateway. And what this does is it provides essentially a public URL for us to call this function with. So we're going to select a trigger. We're going to choose API Gateway. And since we don't already, well, I actually do have some APIs here, but we don't want to choose any of these. So we're going to create an API, and we're going to make this a REST API. So what we'll do is we'll make the security open, which means it's going to be public to everybody. You have the option to make this API key accessible as well. Then there are some additional settings that can probably be left as default, so we don't need to worry about that for now. We'll go ahead and add this trigger and wait for that to finish processing. So now we can see that we actually have API Gateway with a line up to our calculator API function, which means that whenever we call API Gateway, whenever we call the specific URL endpoint, it's going to call the function code associated with this Lambda. So hopefully that makes sense. And now we actually have a publicly accessible URL that we can probably just put into our browser here. And we can see hello from Lambda. Now let's go ahead and inspect this page, and we'll go to network. And let's just refresh the page. We can see that we hit the calculator API. and the response that we got back was hello from Lambda. We can take a little bit of a closer look here and see that this is the URL that we are hitting. This is the request method that we sent up, just a simple get. We sent up some headers as well, and we also got these response headers back. So all of this is what you would expect in the default Lambda function. So nothing much to talk about here. Let's go ahead and put this into Postman to see if we get the same result. So I'm going to create a new request. I'm just going to drop this calculator API in. We're going to send that up. And of course we get hello from Lambda back. So this is generally good practice whenever you set up a new service on AWS. With the default parameters, without doing anything custom to it, you just want to make sure it's going to work in these different scenarios. And you can see just how easy it was to set all of that up. Just basically about 10 clicks. And we have a publicly accessible API. From here, what we're going to do is add a little bit of custom logic, and we're also going to see how we can actually debug this. How can we see logging for this API? If anything goes wrong, where do logs go? We're going to check that out right now. So one thing I want to do is actually log this event so I can see what's actually in this event, so I can know what I can do with it. I would want information, I would want some context from the caller. For instance, what do I want the API to give me back, and what am I giving the API to actually help process that request? So I'm expecting that to come in the event, but I don't exactly know what properties I have inside of the event. So what I want to do is add some code here, console.log, and I just want to pass the event into that. I'll save the function. I'll run my test. We can see that the test succeeded. And then we can look and we can see we have this log here. We have info, we have key 1, value 1, key 2, value 2. The reason that that comes in is because we have in our test event, that's what we're sending up. But what happens whenever we send up a request from Postman or directly from the internet? So the way we can actually read that is if we go to CloudWatch. So let me back up a little bit here. What I want to do is I want to search a new service on AWS, and I want to look up CloudWatch, and I'm just going to select the CloudWatch service here. You can see monitor resources and applications. So this is where we're actually going to be able to see some of our logs. So what we're going to do from here is go to log groups on the left, and then we should see our Lambda calculator API. So these are the logs that are being fed from the Lambda into this log stream. I'm going to choose the latest. You can see the last event time. We have one from 11:18 and one from 11:22. Every time you save your Lambda, you're going to get a new set of logs. So you can see these were the first tests that we were running. Then I made that code change to log the event, and now we're getting a new log stream. So let's open this up. We should be able to see the info from our test event, which is great. But now what I want to do is refresh on the browser to see what happens, and then make the same call from Postman to see what happens. So let's go over here. Let's refresh this page, and then we'll come back to CloudWatch and we'll refresh this. Okay, so we have a new request coming in. We have a little bit more info, a lot more info. And so this is the info that you would get from the browser request, which is really going to be almost identical from Postman. So what we get from the event object, and just as a reminder, if we go back to the Lambda function, remember I'm logging the event that's coming in to the Lambda. And so we're just seeing what's inside that event object. So we have a resource, a path, an HTTP method, which is going to be critical in how we process requests. We have some headers that come in as well, which we probably won't be too concerned with in this tutorial. We have some query string parameters, which we will be concerned with in this tutorial. Some more context about the caller. And then we have this body value, which we're definitely going to be working with in this tutorial. Right now it's null. Now, the two things that we're going to be concerned with, or the three things, will be HTTP method, because this could be get, post, delete, update, so on and so forth. We're going to be concerned with query string parameters to see how we can utilize that. We're also going to be concerned with body. Okay, so those are the three things that we really care about at the most basic level when it comes to REST APIs. So before moving forward, let's run this in Postman and see if we can compare these two requests. So all I'm going to do is send this back up, and we're going to go back to CloudWatch to see what happens. So I'm just refreshing this until we get some more events from Postman. Okay, so there's our event, and we can see that it's really almost identical. Something that will be different is the user agent. The user agent is inside the identity object, which is inside the request context object. And that's going to give us some context about where the caller is calling from. So we can see this is definitely coming from a browser, but this call was coming from Postman. So there are differences, but for the most part, this is the standard event schema for that object that's coming into Lambda. Okay, now what I want to do is see if I can populate this query string parameters object, because what we want to do is ultimately get some context about what kind of job we want to do. For instance, if we want to add or subtract or multiply, and then get some parameters for the values that we want to perform those operations on. So what I'm going to do is custom insert some parameters. So I'll start off by adding a question mark, and I will say x equals 5, and then I'll delimit each additional parameter by the ampersand. So question mark x equals 5 and y equals 1. So let's send that one up, and then we can go back to CloudWatch, wait for that event to come in, and we should be able to see some values in query string parameters. So let's open this back up for our new request. And now we can see query string parameters has an object where we have x and y, where x is 5 and y is 1. And this is a common way to provide context to the API whenever we're trying to get something back from the API. So that's where we're going to start with the development of our API. Okay, so we'll go back to our Lambda, and what we want to do is first switch on our HTTP method object. So we're going to switch event.http method, and then what the switch statement does is it basically says let's look for some specific cases of HTTP method. So for instance, we can say if the HTTP method is get, then what we'll do is we'll write some logic, and in the default case, okay, so what I've done here is I've said if the HTTP method is equal to get, then we're going to do something with the event. If the HTTP method is not equal to get, if it's not equal to any of the cases that we put in here, then we're not going to do anything. So this is affectionately known as no op. So we're not going to do anything if the HTTP method is not equal to get. Now, in the event that HTTP method is equal to get, I want to just log that. And eventually we're also going to be looking for the post method. So I'm just going to copy this, and we're going to be looking for post as well. And these are really two of the most common HTTP methods that are used in APIs. You'll also have some APIs that are doing database operations that will follow what is known as the CRUD format, which is create, read, update, and delete. And so you'll get the get, post, put, delete HTTP methods that are going to be used in that API. But a lot of APIs will just use get and post. That is sufficient for most APIs. And so what get will do typically is read the query string parameters. What post will typically do is read the body of the event. So since I've made some code changes, I want to go ahead and save this. And actually, since looking at the logs is a little bit cumbersome because we have to wait for those logs to come in, I want to actually modify what the body is going to say based on these getters. So what I'm going to do is I'm going to create, or based on the HTTP method. So what I want to do is create an actual const, or actually this would be a var. So I'm going to create a variable, and I'm going to call this response message. And response message is just going to be equal to an empty string for now. And what I want to do is actually set the response message equal to what this console log was going to be. So we'll say response message is going to be equal to that. And then here for post, it'll be equal to this. Okay. And response message is then going to be used inside of this function here. Now for the no-op, what we want to say is the response message is equal to HTTP method is not supported. Okay, so now that we have all of our code changes, we're going to save this function, and then we're going to go to Postman and play around with some of these HTTP methods to see what we actually get back. Okay, so here we have our HTTP method in Postman. We're going to use get, and then we're going to send this up. So here the response that we got was HTTP method is get, which is of course what we expect. If we choose post, we get HTTP method is post. If we choose anything else, it's going to tell us that the method is not supported. So no matter what else we use, method is not going to be supported. So far, everything appears to be working. So our Lambda is getting to the point where it's a little bit annoying to use the inline editor. And I also want to show you guys the workflow to do a basic deployment from a Node.js project running on your machine into the Lambda dashboard. So the first thing we want to do is actually open up the command prompt and make sure that you can type in node tac version. If you see something like unrecognized command for Node, then that means you haven't installed Node.js properly. You need to make sure that you install that properly and make sure that it's setting your environment variables properly. So that is a prerequisite to moving forward, so make sure you have that squared away. Now, if you actually see your version, I'm using version 10, you can be using version 12 as well. Any of the long-term support versions will be sufficient for this tutorial. In fact, we're not even going to be doing much with the versions. We're not going to be installing any packages, so it's not going to matter very much anyway. Now I'm going to cd into my desktop. So cd is change directory if you're not familiar with command line commands. And then we're going to make a directory, and we're going to call that directory calculator API. And then I want to open up calculator API with my code editor. So whatever code editor you use, you can open it up with that. And then after I do that, I can go to the terminal if you're using Visual Studio Code. If you're using Visual Studio Code, you can do the rest from here. You can just type npm init, and then it's just going to ask you a couple of questions about the project. You can just enter through all of those. You can do the same thing from command line. You can type npm init, and that's the exact same thing. So I'm going to open up this code editor here, and we can see that we have a package.json file which comes with every Node.js project, but we also want to have the index file. So we're going to create a new file, index.js, and I'm just going to copy in the current state of our Lambda. So whatever code you have in the inline editor inside of your Lambda, you can just copy that into here like this. And so what I want to do first before making any further changes to the API is do a little practice run for actually deploying this. So I want to deploy this from my local environment into the Lambda to make sure that everything is still going to work properly. And then I know that my deployment method is valid. So our method of deployment is going to be really basic. We're not going to do anything fancy in this video. We're simply going to find our directory, and we're going to compress it into a zip file. And then we're going to call that our Lambda zip. So this is our deployment zip file. And then we just go back to the Lambda dashboard and upload this zip file into our project. So we can choose this actions dropdown and choose upload a zip file. And then I'll find the zip file that I created and upload that. You might get an error here, but don't worry about that. The next thing you want to do is change your, let's see here, let's go back. You want to scroll down until you see basic settings and then choose edit. We have a handler function here. By default, this is just index.handler, but we need to change that to look at calculator-API. So we'll go into edit and make sure that your handler looks like this. Then we'll just save that. And then you'll see in your inline editor, now you have the calculator API directory that you created on your local machine. You can see the package JSON file in here. And so if you do want to do some inline editing, you can also do it from here. However, at this point, since we've already set up our local environment, I would recommend not doing any inline editing in the browser and just keep doing your editing on your local machine and carry out deployments as usual. Now that this is saved, we can go back to our endpoint on the browser, and if we hit refresh and we get a response back, then we know that our deployment is actually working. Now we're going to organize our code a little bit here. What we're going to do is create a new file, or actually a new directory. So we're going to create a new directory. We're going to call this source. Our source directory is going to have all of our additional code. So the index file is just going to be the entry point of the application. If you remember, one of the principles of RESTful APIs is that it's layered, which means only the top layer is going to be exposed to the clients or the programmers or the callers, right? So the index.js file can be thought of as that top layer, and everything else is going to be obfuscated or abstracted within this source directory. This will be all of our additional processing code. So I'm going to create another directory in here called Lambda. And so these will be our specific Lambda functions. Now we might have another directory in here in our source directory. We might have another one called util, which might access helper functions such as logging. We might even have another folder in here called services, which would be accessing code files that help us with different AWS services and how to connect those various services. And then we'll have our Lambda directory, which will be specific to the Lambda function. So I'm going to create a new file inside Lambda, and this is going to be called calculator.js, and this is going to be our processing class for our API. So I'm going to create a new class called calculator. And this will end up having some public functions, but I'm going to export this as a new calculator object. Okay. And so this class might have something like add, we'll have x and y. It might have subtract x and y. And let's just start off with those for now. So add and subtract, and we're exporting this class as a newly instantiated object. So from our index class, our index file, what we want to do is actually access that calculator. So the way that we do that in Node.js, we can say const calculator is equal to require, and we're going to find the path that the calculator file is in. So that is going to be inside of source/lambda/calculator.js. And so by doing this, we actually have access to the calculator.add and the calculator.subtract functions. Now let's just focus on our get HTTP method case for now. What we want to do is get the x and y from our query parameters. So we can say const params is equal to events.query string parameters. The next thing we want to do is actually build out this response message. So I'm going to get rid of this line and I'm going to modify the response message accordingly. I'm going to say response message is actually going to be equal to, if I use the tilde string format, I can actually add variables inline by doing something like this. So I can say params.x plus params.y is going to be equal to the value that's returned from calculator.add params.x params.y. And so I'm calling the function calculator.add. Remember, calculator comes from the accessor that we declared up at the top of the script. And I'm passing in params.x and params.y. If we look back at the calculator script, we can see that we have this add function and it's accepting an x and a y value. So let's go ahead and finish implementing this add function. That's simply going to be return x plus y. And for subtraction, we're just going to say return x minus y. Back in our index, we can just verify that we have everything the way that we want. We're setting our response message equal to params.x plus params.y is going to be equal to the result of adding x and y. So hopefully this makes sense. And what I want to do now is actually deploy this to test it. So I'm going to delete this version of the zip, and I'm going to compress that again. Then I'll go to the Lambda dashboard and upload the zip file so that we can actually test this code. So I'll go to Actions, I'll upload the zip file, and I'll save that. Let's refresh the page and see if the inline code is updated. And I wouldn't focus too much on this inline code. It looks like it doesn't update. Let's try so in the inline code, if we close out of the file and then open it back up, it looks like it does update. Try not to get too confused by the inline code editor. It's not completely fleshed out as a service, but we can actually see that our Lambda was updated. We got the new code files in here, so everything looks okay for now. And that automatically saved. So let's test this out. Let's go back to Postman and see if we can drop these parameters in, params.x and params.y, and actually get the correct response back. So from Postman, what I can do is add my parameters inside of these fields. I can say x and y, where x is going to be, let's say, equal to 1, and y will be equal to 1. Let's send that up. And so this is kind of funny. It looks like what we did was some string operations. So all we did was append the strings. And the reason that probably happened was because these values were read as strings in Node.js. So let's see if we can actually fix that up. Okay, so obviously we're going to be needing to do some processing on our query string parameters. So let's make this a var so that we can modify it. And what we'll do is we'll say params.x is going to be equal to parse int params.x. So all we're doing is we're converting this, which is a string, into an integer value. And then we'll say same thing for y, params.y is equal to parse int params.y. So we'll go ahead and package this up and deploy it, and then we'll test again. Okay, so I've redeployed my API. We can see x equals 1, y equals 1. And the value that I get is 1 plus 1 is equal to 2. If I change this to something like 52 plus 1, then we get 53. So it looks like that's actually working now. Now, one thing that we need to do before we move forward is some parameter validation. So what if I pass in, there's two things we need to check for. First, we need to make sure that our params are actually x and y. The other thing is that our parameters are actually integers. So if I were to say, for instance, x is equal to b, we might get a result back, but it might not be exactly what we expect. So here we get nan, which is not a number, plus 52 is equal to not a number, which might be fine, honestly. We might not need to do any validation on non-number characters because the response that comes back is pretty self-explanatory. However, if we were to say, let's see, if we were to say x is equal to 1 and c is equal to 2, now we don't have a y value, and so we have 1 plus nan equals nan. However, that might not make much sense to the caller because clearly 2 is a number, so I'm wondering why I'm getting not a number there. So we might need to tell the caller that we're expecting a certain type of parameter name. So we're expecting a value of x and y, and then the caller can say, oh, I'm using c, I actually need to be using y here. So if we could return that information back to the caller, that would be fantastic. So let's go ahead and try to validate these parameters and provide some useful feedback to the caller. So what I'm going to do is actually create a new function. This is going to be called validate params. That's going to be equal to a function that accepts some sort of parameters. And then that's also going to return the parameters if they are formatted correctly. And if they're not formatted correctly, then we'll return some sort of error. So what we can do is say, let's see, we could say, let's create a variable called return. We're going to set that equal to params. We could say ret. First we could say if ret.x is equal to undefined, or ret.y is equal to undefined. Then we could return an error. So we're going to return a new object which has an error, and that error is going to be our ultimate response message. So we'll say the error is going to be unexpected params expected parameters x and y to be integers. So there we're providing a little bit of feedback back to the caller, and then what we'll say is otherwise we can say ret.x is going to be equal to %, ret.x, and ret.y is going to be equal to %, ret.y, and then we can return ret just like that. Then what we do up here is we can say, well, now we could say const params is going to be equal to validate params. And then we'll do a check here. We'll say, what we'll do is we'll say if params.error. So if there's an error object within the parameters that were returned from this function, then what we can do is just say response message is equal to params.error. Then we can add an else, and then otherwise the response message is going to be equal to what we already had in the first place. So here we have a little bit of parameter validation, which is typical in APIs. And again, this is all still on the top layer. This is a little bit of processing the request and the context of the request to make sure that the API is actually going to be handling the request properly. So let's go ahead and deploy this and make sure that our validation works and we get the expected error back. Okay, so after deploying our new code, let's just make sure that this simple case works. And now the new case that we're checking is if we don't have the x and y parameters. So if this is equal to c, for instance, I'll send that up. We get unexpected params, expected parameters x and y to be integers, which is exactly what we want. Now, again, we didn't cover the case where the value was a non-integer value. So if we were to put a in place of 1, then we'll still see nan plus 2 is equal to nan. But as the caller, that should be pretty easy for me to figure out on my own, since I'm clearly not passing a number up in the parameter. So we're going to call this request validation sufficient, and we're going to move on. Now, one thing that we're not doing yet is actually checking if we should be adding or subtracting or what other operation we're supposed to be doing. So what we can do is grab the appropriate calculator function based on the path. So if we go back to Postman, and we can sort of imagine what we would like to see here. What we'd like to see is if we were to pass calculator API /add, then that makes a little bit more sense, or calculator API /subtract. Then we know that we're subtracting 2 from 1, or we're adding 1 and 2 together. So we can dictate, it would be nice if we could dictate the calculator function within the request URL. So let's see if we can figure out how to do that. Okay, so one value that we actually get from the event is the path. And something that we can do here is we can say var func, so this will be short for function. We'll set that to null for now. And then we'll say, let's switch the event.path so we can get some context about which function we should call from the calculator. So the first one will be /calculator API /add, and I actually need to add the case value here. Okay, so that'll be our first case. The second case will be subtract, and of course we'll want a default case. So in the event that neither of those are the path, then we want to probably return a response that tells the caller that they're not using an appropriate calculator function. So let's return a response here. We can say return status code, and maybe we can have a status code 502, which is internal server error, and then we'll have a body, which is just going to be essentially, it'll just be the string error. So we don't even have to stringify that. We could just say that this path is unsupported by the API. Okay, so one of the things that we're going to need to test whenever we deploy this is whether or not we can use a path that is not equal to one of these two. Okay, now if the path is equal to add, then we want to say the func is going to be equal to calculator.add. And actually, let's put this all on one line just so it's a little bit more compact. I usually do this whenever the case logic is really simple. So I think it's acceptable in that case. So for subtract, we can say calculator, the function is equal to calculator.subtract. There we go. And then what we do is we use this function here. Okay, so since we have that function defined, and we know that it's not going to come through unless it has a value, because we're returning on this default case. So we know that func is going to be not null. We know it'll be a valid variable, a valid function. We can pass this in and call it just like that. So this gives us a very extendable way of providing more functionality to the calculator. Let's go ahead and deploy this and see if it works. All right, so back in Postman, we can see we have our default, our original URL. This should no longer work. We should get the error that this is an unsupported path. So let's go ahead and send this. So this path is unsupported by the API because, again, we're not specifying add or subtract. So if I were to add this new path to the end of the URL, then it should work. Now we actually get a message that says missing authentication token. If you recall, we're actually fronting this Lambda with API gateway, and this is typically what you get in response if the URL is invalid or if it's not supported by API gateway. So we need to actually go into our API gateway console and make sure that we add support for these custom functions. So let's figure out how to do that really quick. So inside the Lambda dashboard, I'll click on API gateway up here, and then I'll go to the calculator API dashboard. So this is the API gateway dashboard. You can see that we do have support for the /calculator API path, but we don't actually have support for custom paths or unknown paths, or what API Gateway will call proxies. So we're going to add a support for a new method, or a new resource rather, and this resource will basically be our proxy. And we actually get the ability to just configure as proxy here, and it'll do everything for us. So this is how you would add the proxy. And what this means is that we can basically append any path to the end of our calculator API path. Okay, so I'll create the resource. We can see that we have the ability to have /calculator API /proxy, which is / whatever we want, and we can perform any method on that. So this is a very generic way of building out this API and the API Gateway rules. But for now, this is going to be fine for us. And once we make changes to the API Gateway console, we want to go ahead and deploy that so that it's up to date. We can just deploy to the default stage. And it looks like it needs us to create an integration for this method. And so let's say we just need to point this. So we need to point this method to our Lambda, which is the calculator API. And then we'll save that. And now we should be able to actually deploy this. API Gateway can take a little bit of time to deploy, so wait 1 to 5 minutes for this to actually finish deploying, and then we can go back and start testing on Postman. Okay, so now we should be able to test whether or not this add function is going to work. So let's go ahead and just try to send this up and see what happens. Okay, so after sending it up, we can see that with the add function, we get 1 + 2 = 3. Let's get rid of the add path and make sure that we still get this error, which we do. Now let's try the subtract path. So /subtract, we'll send that up. And then we get 1, well, we're still getting 1 + 2 = -1, but that's because we didn't update our string in our response. So what we should do now is just actually return the new value that gets returned instead of trying to make this a readable response. Because if we want to make this readable, it's going to require a little bit of extra effort. And so what we can do is actually just return the response value. So in our code, instead of having this response message set up like this, what we could do is we could say our response message is actually going to be equal to a JSON object, which would be equal to value, and that'll be equal to func params.x params.y. And then we can get rid of this string here. And so we have the case for get, but we're not doing anything with post yet. And we don't necessarily have to do anything with post. I just wanted to show you guys what we could do with post and how we would actually post bodies up into the API through Postman. So sometimes post is used whenever we just want to update something on the server. Sometimes post is used whenever we have a large amount of context that we need to send up to the API. So it would be so much context that it wouldn't be worth putting it into the query string parameters, because then the URL would just be too long and convoluted. So sometimes we use post for cases like this. And what we can actually do is probably end up creating a function out of this so we don't have duplicate logic. But what I'll do is I'll copy this case from get and I'll copy it into post. The only difference that we're going to actually have is instead of using event.queryStringParameters, we're going to use event.body. And because the body by default comes in as a string, we want to make sure that we parse that into a JSON object. So we'll say validate params on JSON.parse event.body. Okay, so what we're going to be testing with this new deployment is that we actually get the response message back as a value, and then that we can actually use this post method the same way that we're using the get method. So let's go ahead and deploy this and see if we can use get, if we can use post the same way that we can use get. All right, so let's go ahead and rerun this request URL that we have in Postman already, and we'll see what we get back. Okay, so we actually got an internal server error, which is, I suppose, good from a learning perspective, so we can figure out how to debug this. So let's go back to CloudWatch and see if we got any error messages whenever this code is run. So we'll go to CloudWatch and we'll go back to our log stream. We'll look for our latest event time, make sure we refresh to make sure we get the latest, and then we should actually see some errors. So we have a syntax error here. Params has already been declared. So it looks like we may have declared that as a const, and we did that twice. So let's go back to the code and fix this syntax error. Okay, and so what it was referring to is that we have const params declared twice, and we can't do that. So what we can do is perhaps, and I can see this is actually sort of faded out. We actually don't need a break right under return, so I'll do that while I'm here. But we need to figure out a way to essentially, we need to make sure that this is a single variable that's only declared once. So one thing that we can do is maybe make this a variable and initialize it to null. And I just had a thought here because this code is the same on both cases, it looks like. So I'll actually copy this. This is going to clean up our code pretty nicely. And I'll delete it from each one of these. And then the assumption is that if params is not null, so if params is not null, then we can run that code. Okay, and so that saves a little bit of code for us as well. So all in all, a good thing that that error was caught. And so just to go over this, what we did was we made sure that we weren't declaring params twice so that we can avoid that error. And then we also cleaned up the code, the duplicate code that we had here. And we checked to see if params is not equal to null because we do initialize it to null. So if it's not equal to null, then we can continue with running this operation on the calculator. Let's go ahead and deploy this and make sure that everything is good. Okay, so back in Postman, we're going to try to send up this same request and hopefully we don't get any errors, and it looks like we don't. Now we get the response as a JSON object. We get the value field that's passed back with the value that should be returned from subtracting 2 from 1. So 1 minus 2 is definitely -1, so it looks like that's working. And if we do this with add, then that works as well. Let's go ahead and double check that we don't support unsupported paths, and it looks like that's still working as well. What if I were to say multiply here? So when you're testing your APIs, you just want to test out as many cases as you can think of to make sure it works exactly the way that you want it to. And eventually we will add support for other calculator operations. Or maybe that is something that I would recommend you trying to implement on your own. I think that would be actually a pretty good exercise. So I think I should challenge you guys to implement multiply and divide and maybe even powers on your own. So implement as many calculator functions as you can and try to extend this API beyond what this video is going over. Now we have support for get, but now we want to add support for posting. So remember, whenever we post, the API is going to be parsing the body. And essentially what we want to do now is change the value from get to post. We want to get rid of these parameters here. So all we have to do is say add. And we're going to add in our body. And our body needs to be JSON format. So we would choose inside the body tab, we would choose raw, and then we would choose JSON from the dropdown. So we're going to create our own custom JSON. And our JSON needs to be, remember, we're expecting X and Y. We're expecting X and Y to be strings. So we'll say X is equal to 1, and then we'll say Y is equal to 2. And if we run this, we should get a response back. Okay, so because we're using post, we are adding a body to the request. We don't actually have any query parameters, so it actually looks pretty good in terms of how the request URL looks. We're using the add function, which means 1 plus 2 is definitely going to be equal to 3. Let's just see what happens if we don't stringify the number. And it actually still works, which is great. So we don't need to rely on that. And let's use the subtract function here. So if we subtract 2 from 1, then we should get -1. So it looks like everything is actually working as expected. And of course, the cool thing about this is we can do the exact same thing from the browser. So I'll take this up to the browser. Okay, and I'll add the query params, x is equal to 2 or x is equal to 1. Doesn't really matter. Y is equal to 2. And we get the value of -1. So that's pretty much it, guys. Again, I would encourage you to extend this API to support other functions such as multiply, divide, and maybe even powers, or whatever else you can think of for a simple calculator API. Definitely looking forward to what you guys create, but before we close this out, I do want to just go back over our code and make sure that we understand it thoroughly. So this is a really simple example of an API, but there's a few things that I do want to go over to make sure that we understand exactly some of the core tenets of RESTful APIs. And so in this index.js file, remember this index is the top layer of your API. It's one of the principles of RESTful APIs that only the top layer is exposed to the caller. And so the only thing exposed to the caller is going to be context processing, and it's not going to be concerned with how we process the request. So in other words, this is a simple calculator API. The top layer is not really concerned with how the calculator actually processes functions, and the caller is definitely not concerned with how the calculator or how the API processes requests. It just needs to know that it sent the right information up and it's actually getting the expected information back. So what that means and what that implies is that we probably on our top layer need to have some sort of parameter validation. So that's one of the prerequisites. We need to make sure that we're getting the correct parameters. For this API, our parameter requirements were that we have one X property and one Y property. And if we don't have both of those together, then we send back an error to the caller and tell them that we need to have these parameters. We need to have the X and we need to have the Y integers. Then we do some further processing just in case the X and Y aren't actually integers. We want to make sure if those are string integers, then we actually parse those into the into numerical integers so that we're not actually just appending strings. Remember, whenever we first created the API, we tried 1 plus 1, and the result that it gave us back was 11. That's because it was appending strings instead of adding numerical integers. So again, parameter validation is very important for RESTful APIs. The other thing that you may be doing in your RESTful API is actually parsing through the path that's being called on your API. And there's a couple different things you can do with path parsing, but what we did was we used the path parsing to determine which function, which calculator function that we actually wanted to use. The next thing you would do in a RESTful API is to add support for specific methods. In our API's case, we aren't supporting methods unless they are equal to get or post. And in the event that we get an API request that isn't equal to get or post, we simply send back to the caller that this HTTP method is not supported. Moving down, if we actually do support the method, then we actually do some processing on that method. And so that's what we're doing down here, is we're actually processing that method. And the processing is really simple, but essentially this is what you would have in a real world API that's RESTful, is you would basically abstract everything into a single function. We would do whatever validation we need to do on the request, do whatever contextual parsing we need to do on the request, and then we would pass it into some sort of processing function, which in this case is either adding or subtracting two numbers. Finally, what we want to do is make sure that we're returning something. So no matter what, we want to make sure that we have a response message that's coming back to the user. And then finally we return that response. So I hope this is a good introduction to RESTful APIs and also how to use various AWS services, which are still popular today and probably are still gaining popularity, to be honest. All of the things that we talked about today are going to be excellent resume skills that you can add to your resume. And I encourage you to continue practicing, especially if you want to go into this field. You want to be able to have a couple of these types of projects under your belt. So let me know in the comments what you thought about this, if it helped you out. What else can I do to expand on APIs? What ideas do you have for APIs that maybe you want to know how to implement? Maybe we can talk about those and have a discussion in the comments down below. But as always, everybody, thank you so much for watching. Thanks for supporting the channel. If you want to get that Screenbar Plus, then check out the Amazon link in the description. And again, a huge thank you to the sponsor of today's video, BenQ, for sending that light bar over to me. Really appreciate you guys, and I'll see you all in the next tutorial.